Hello, hello. All right, everyone. Next up, we have Mr. Tony Parisi. I know you like to introduce yourself, so I give you a real short one.
Hey,
Please welcome
all
Tony
right.
Parisi.
Thank you, Carl, for that rousing introduction. Hope everyone's had their coffee and is ready to get through the rest of the day. A year ago, at this very event, and I was graciously invited by Carl, and I did a panel there. Some folks from the Mozilla browsers had a crazy idea, and of course, if people know me and my background, having done a lot of web and 3D graphics for years, I said, no, it's a great idea. You know, what does that entail? And we started discussing that, and then a few months later, the folks from Mozilla actually had some code ready to demo. I run the San Francisco WebGL meetups. I'm a WebGL developer. I'm a web developer. I've been doing 3D on the web for a long time. I'm also an author. I write books for O'Reilly & Associates on WebGL and a upcoming one on virtual reality, including WebVR and other topics. And anyway, Josh said, we got this cool thing, and he came and demoed at my WebGL developers meetup last June. He not only showed up, but he brought Brandon Jones from the Chrome team with him, and they had VR working in both Chrome and Firefox and working basically the same about a year ago. And it's been a really wonderful, interesting trip, and we're going to talk about how that works today. And in my talk, WebVR, VR without borders. But first, we want to get into maybe why we might want to do this. Let's talk about VR apps today. You know, we're creating some wonderful experiences in native code. But as we've all seen, especially if you're running on a PC, you end up going to some portal like Oculus Share, you download a bunch of stuff, you install it. A lot of these are demos that don't even have a signature file with them, so you have to go through some extra rigmarole to even launch the application right now, though that's changing. These things are getting professionalized. But that's the way it works in a desktop. It's even a little more cumbersome if you're on a mobile phone. You're going through an app store kind of interface to do that, and you have to install something after and then you've got to download. It's all this process, right? This stuff is built with proprietary tools. These tools are great. Unreal and Unity, Crytek, we're seeing some amazing VR experiences built with those. None of us as developers, if you care about this, have access to the source code to those engines or the tools. That could be a problem for some people. And in general, the creation of VR so far, in the large, has been the story of a closed culture, the game development culture. People do not like to share code. They don't like to share secrets for the most part, and they want to keep their IP real close. And it's also a place where it's really for experts only. You need an expert content creation team, and this is getting to be even more the case as the specs are getting published for the machines and the specs are getting published for software developers for what it takes to build a good VR app. John Carmack saying, 90 FPS or more, all of these crazy things we have to follow as developers. They're important. We don't want to make people sick. But at the same time, there's a lot of folks who want to build VR applications, and they might not have access to or the resources to pay for a crack game development team. So, what is a poor developer to do in the world of VR? Well, let's contrast this with web applications today. If you build a web app, how many people in the audience are developers of some sort? You write code. Okay, good. How many people are game or VR developers who use a native tool like Unity or Unreal? Yay? Great. I know Tipatat's here now, even though I can't see. How many people have built a web page? Okay, so that number of hands was greater than the previous number, right? A lot of people know how to build web pages. What's great about the web? There's a lot of things that are great about the web. When I want to experience content, I click on a link. Maybe someone emailed me something. I got a link to something in a tweet. I click the link. I just see it. I don't see a site that says, go download this app in order to see the thing that you just heard about. I don't get a link to an exe that I have to download and install. I see it. I didn't have to go through an app store to actually get that. As a developer, I didn't have to upload something in an app store for someone to approve. Aren't we all delighted that Palmer Luckey said, guess what, Oculus isn't going to block porn. Yay, that's wonderful. And that may be the case until Oculus decides, I don't know, they're going to have an app store for some reason on a native platform. I'm not even talking about Gear VR. We'll see. But assuming that's true, you still got to go download a damn exe. Here's what's crazy about that. You even have to do that, like, if you want to see a video on the Gear VR, for example, it's a video. Guess what? You got to download a different app for every frickin' video. What's that? That's not only crazy, that's freaking stupid, right? That's stupid. So wouldn't it be nice if I could just hit a link, see a video, play on my website, and 360 in a VR, and put on my head mount, right? As a developer, we also care about having a choice of tools. We like freedom. We like to be able to pick the tools we want. We like to get at source code for those tools and use them in our day-to-day stack. And there's a lot of freedom there when you look at doing web stuff. And in general, the web is a culture of collaboration. The web was built on standards, people cooperating, sharing code, working on protocols together, to the point where I can not only get source code to engines, but source code to people's websites. Anyone? View source button on your, your menu on your browser. That's the way a lot of people learn how to build websites. So overall, no barriers to entry, ultimate freedom. So as VR developers, wouldn't it be awesome if we could have the power of virtual reality and virtual experiences with all of that freedom that comes with the web? That would maybe be the peanut butter and chocolate of VR development. I know it is to me. But you say, that's crazy. How can we do VR development in a browser? Well, I want to make sure people are aware of this. If you haven't heard about it, I think Dylan talked about it briefly in the last talk. There's a technology called WebGL. It is 3D rendering for your browser. It does real-time 3D, and it runs everywhere. It runs in every browser on desktops. It runs in Chrome, Firefox, Opera, Safari, Internet Explorer. It runs on all your mobile browsers. As of last fall, it runs in iOS, so it runs in mobile Safari, runs in mobile Chrome on all Android devices. So we're talking 3 billion seats that do 3D today already, and that is a big part of deploying VR. Well, it gets better than that because, as I mentioned when I got up here, there's now a web VR API. I'm going to go into a little bit of technical detail on that in a slide. But it basically allows you to track a head-mounted display's position and orientation and display in full screen stereo rendering, including with Oculus distortion. Right? So there's a spec up. It's a draft spec from the Mozilla folks, intended to be an internet standard at some point. But right now it's an experiment. And it's an experiment that's been going on for the better part of a year. And so if you go get a nightly build of Firefox or a nightly build of Chrome, you can actually then just connect your Rift to it. And after you've got your Oculus already set up, you've downloaded your SDK and the things you do as a developer, you can now have no download, instant access to VR on the web. And I'm going to show you a quick demo. Here's my Chromium. And I just preloaded it in case the internet gods were against me in terms of bandwidth or it not happening. But it does not take long to download this. And this is a version of Quake that Brandon Jones from the Google Chrome team had ported to WebGL a few years back. And then when he was working on the WebVR API, that was the first demo he kind of put together to make sure it all worked. And so now what I have is Quake connected to my Oculus Rift. I'm going to put it on just for a minute. So you see how cute I look with the Rift on my face. That's not going to work because it's not coming in here. I'm going to go blind, so I won't do that. I'm seeing my Mac desktop up here. But anyway, you can imagine that. And now using the WASD keys, I can actually move around the scene. And I'm moving around in full immersive VR. And it would look spectacular if it was in my display right now. Oh, I fell. I lost that level. But it works. And it's a very simple API, especially if you're already doing web development in WebGL. It's super simple. We'll go back to that. It really only has 3 things. And we don't have to labor the technical details here. But it's really simple. So if you're already building a web app and you know how to render in WebGL, you have to do 3 things. First, you have to find out if you have any VR devices connected to your browser. You ask the browser, give me a list of the virtual reality devices. And a device is either an HMD for display or it's a position tracking device that tracks position and orientation. You save those away. For the display part, you get the camera parameters so you know the interocular distance so you can do your 3D render with the 2 eyes. And then that's all you do at setup time. And then you're going to do 2 other things with that. The next is you're going to render in full screen for VR. Browsers already have a full screen API for doing game development. Just 1 line of code. You say, hey, browser, I'm requesting you to go full screen. Now, if you ever played a full screen game on the web, you'll get that annoying prompt the first time. And you say, yeah, I'll let Mozilla give me a full screen game. You say yes once. You never have to do it again. Now you have a full screen game. By passing it, if you look at that bottom line I've highlighted there, into request full screen mode, you pass a handle to that VR HMD device, and now it will render for you with the Oculus Rift distortion. And then the final thing you have to do is you have to do the head tracking, the position and orientation of the HMD, which you then feed into your game or your simulation. And you basically set the camera position and orientation, which we're doing down here at the bottom. And that is it. So if you're already building WebGL games, From an API standpoint, of course, design and all that and building a good VR app is the same, whether you're native or web. That's all you have to do to take your WebGL and turn it into a VR app. If you're writing for Google Cardboard, it's actually even simpler. All you have to do is a side-by-side render, and the web browsers already have all the accelerometer tracking. There's an API for that. Of course, as we know, that cardboard-based accelerometer tracking is slower, and that 90-degree field of view, not as good as a Rift, but for, if you're doing cardboard anyway already, it's as easy as writing mobile browser code and doing a stereo render and tracking with the accelerometer. Super simple. This eye chart is by way of just saying, you do have a huge choice of tools here. You can use open source libraries, just scene graph libraries to do your 3D rendering and make your own game engine on top. You can use any one of a number of free in-browser game development tools. So imagine you go into a browser page and you've got something that looks like Unity with a 4-view, property sheets, or single view, depending on how you configure your desktop. You can build and assemble your game, add behaviors to it, and publish all from within a web page. And those work today, like Verold, Goo, and there's full-on game engines like Turbulence and Play Canvas that are not only as good as that and have level editors, but they're open source. And then there's a bunch of other libraries, and a bunch of freedom of choice there. And even if you love your Unity or Unreal, they now have WebGL publishing options, and these are great. They use a weird hack of a technology which cross-compiles the entire code base of the game engine, either Unreal or Unity, and outputs a giant pile of JavaScript, 10 or 20 megabytes of JavaScript that is the compiled code for that engine. It's not the game, and then your game content comes on top of that. So that's wonderful if you have a full sort of deep game experience. Your user doesn't mind a 2 or 3 minute loader bar. It's a little anti-web. Most web pages are supposed to load in 2 seconds, right? But if you're doing a web game and you have a core user, they're probably okay with this 2-minute wait. That's still better than the delays of a big download of a 1 gigabyte game that's done in native. That's a pretty good solution for that. So if you already love your Unity, you're doing your native stuff there for mobile or for desktop native, and you want to try out some web publishing, these export paths are there. They're real for WebGL, and they're adding the VR support too. So that's a pretty nice and promising aspect of this whole thing. You don't need to learn a new tool set, and you can have this instant web publishing capability. Now, there's some challenges here. The browsers have never had a reason to try and refresh the display at more than 60 frames a second before. And now they need to, because we know we need to do our head tracking at least 75, preferably 90, even 120 hertz. You might think, I can't render a JavaScript scene at 120 hertz per eye. There's no way my JavaScript will run that fast. It's not true. The JavaScript interpreters have gotten super fast. WebGL itself is a really light API, goes straight to the hardware. So you need a smart engineering team building a game engine that can go fast, or you need to know all the JavaScript tricks, but you can do it. That is not the issue. It's the browser itself not being able to talk to the display and refresh at faster than 60 hertz, because when it tries, it gets kicked out of extended mode and all this sort of driver mode level nonsense that the browser makers claim and swear they are working on. And this is giving them a reason to unthrottle, so they're going to hit 75 or 90 FPS, and you will get, not only beautiful and smooth rendering, but nausea-free head tracking as well, which is fabulous. And then, of course, the other thing is, on the web, we're dealing with these frameworks, and they're open source, and that's the beauty of it, but that's also kind of the scary part of it is you're often in DIY mode and having to fix your own, fix your bugs, even though it's in their code. You might end up contributing a lot of fixes to an engine that's out there that's open source. It's not as commercialized as a Unity or Unreal. But again, that may be the beauty for some folks. So it's a bit more of a wild web world, but you have so much more freedom. Now, if you want to know more, there's a great showcase that not only talks about design issues and tries to kind of bring the best out of these web experiences, but it also has code examples up there. Mozilla's been creating this showcase, and it's been up online for about 6 months now, called MozVR. So go to mozvr.com, and it's got highlights on all the latest APIs and about a half a dozen demos. I actually built one of them with the Mozilla team. And these slides will go up later. Here's a list of links. The bottom one, I've got a little GitHub starter kit thing, so if you know WebGL and 3JS, this will show you how to quickly create a VR application and do something dumb, spin a cube around, but it'll get you going. And then couldn't resist the unabashed plug before I have to, I'm going to get the hook here, but I am halfway, or a little bit more than halfway now, thankfully, through my 3rd book for O'Reilly. I don't know what I was thinking, but this is a book on how to learn to program in virtual reality. JavaScript for web, Cardboard using both Android, well, 3 ways, Android, Unity, and WebVR. some native Unity stuff, and some native Android with Java. So it's a bit, across the board. It's a bit broad in terms of the technology, but it's all about getting up to speed and learning how to develop for Rift, Gear VR, and Web VR, and Cardboard. So, I hope you check that out. It will be an early release probably in about a month. And make sure Carl puts the word out about that. So with that, thank you. We don't really have time for Q&A because Philip's coming up next, and I know he's got a big presentation in his own hardware setup. But if you want to hang out outside, I'm happy to answer questions for about 10 minutes. All right, thanks very much.